Hello, today we're going to look at speed time graphs. Time graphs are graphs where speed is plotted as a function of time. So as time passes, we're going to plot the speed that we have at each point in time. Let's draw a line. We are starting at time is 0 and speed is 0. Yes, at the origin, time is 0, no time has passed, and our speed is at 0. And I'm going to do this. Now, what does that mean? This no longer means this is not distance, this is now speed. So, over this time period, our speed is increasing. So if I'm on a moped, my moped is going to go, it's stationary, right? And then it increases in speed. So I'm increasing in speed. I'm not traveling at a constant speed. I'm increasing my speed. That is called acceleration. So what is happening here? Acceleration is happening. All right. Then I do this for a while. What does that mean? If this was a distance time graph, this would mean that I'm not moving, that I'm taking a break. But speed, in this graph, time is passing, but the speed is neither increasing nor decreasing. That just means I'm traveling at a constant speed. Yes? Constant speed. Okay, and then yes, then this happens. Once again, I am increasing my speed over a certain time period, right? I'm increasing my speed. So it's acceleration again. But what can we say about this acceleration compared to this? Here our speed is increasing. Here our speed is increasing at a greater rate, right? We're increasing our speed faster. So greater acceleration, greater than here, right? We're increasing our speed faster than we were increasing our speed here. And we can tell by the steepness of the line as well, right? The steepness of the line shows that the acceleration here is greater than there. Okay. And then what if I do this? What does that mean? I'm still driving at some speed above 0, so I'm not standing still, but I'm going from a higher speed to lower speed until I'm no longer moving. So I am decreasing my speed slowly, or actually quite fast. I'm decreasing my speed, which is called deceleration. Deceleration, decreasing my speed. Okay. There's two rules that you need to learn. In a speed time diagram, speed time graph, such as this one, the acceleration is equal to the gradient of the line. So the gradient of this line tells us how great the acceleration is. Here the gradient is higher, so the acceleration is higher. And the gradient of a line is calculated by the change in y, so the change in speed, divided by the change in time. Yes? We'll come back to that with an example. You probably already noticed that when we're decelerating, our gradient is negative. So decelerating is negative acceleration, right? Another thing you need to know is that the distance we traveled is the area under the graph. You can write that down, but I'll explain it in just a minute. Yes, the distance that we traveled, because distance is not plotted anywhere here. We have to calculate it. And we're going to find out that the way to calculate it is actually by finding the area under the graph. Okay. First example of finding the acceleration. Yes, so we're first going to look at this rule in an example, and then we're going to look at this rule in an example. So first the acceleration one. I'm going to draw a line like that. Say this is my speed time graph. Time. Here's 10 minutes past, here's 0, right? Here my speed is 10 kilometers per minute, here my speed is 20 kilometers per minute, and here it's 30. Okay, what if I want to know my acceleration on this line? Acceleration is the change in speed divided by the change in time, or we can say the time that it took to change my speed. And in this case, my change in speed is, I went from 0 to 20, so 20 kilometers per minute. We're going to divide that by the time. How much time has passed? 10 minutes. So my acceleration is 20 divided by 10 is 2. Now look at the units. Kilometers per minute, right? Kilometers divided by minutes. So divided by minutes squared. Acceleration and deceleration are always measured in a distance unit divided by a time unit squared. Yeah. Let's look at I just used green for my orange line. I wanted to use orange for my orange line and then blue for my blue line, but oh well. Let's look at this graph. We're not looking at the blue line. Let's find out the acceleration over this time interval. Acceleration is change in speed. How much did we change our speed? Our speed went from 30 to 0, so it changed negative 30 kilometers per minute. And how long did it take? What's the change in time? It took us 10 minutes to go down by 30 kilometers per minute. Negative 30 divided by 10 is negative 3 kilometers divided by minutes, minutes squared. Yes, so this is a negative acceleration, which we call deceleration, and this is a positive acceleration. Instead of defining it by change in speed over change in time, you could just say acceleration is equal to the gradient. If I were to ask you what is the gradient of this orange line, you would say, well, it's the change in y over the change in x. Change in y is 20, change in x is 10, 20 divided by 10. Yeah? What is the slope or the gradient of this blue line? Well, the change in y is down 30, so negative 30, over positive 10. Negative 30 over positive 10. And then add your units. Yes? Now an example of how to calculate the distance traveled from a speed time graph. Speed is in kilometers per hour this time. Time is in hours. This time the hours are in front of the dots. It's like, yeah, you know how that works. What if my graph looks like this? So I'm going at 120 kilometers per hour for my first hour. Yes? Then for the next 30 minutes, I steadily slow down to 110 kilometers an hour. Yes? And then I stay at 100 kilometers an hour for another 30 minutes. And then I'm where I want to be. Yes, so I stop driving there. I'm not going to draw me stopping. Okay. If we want to know how far we traveled, let's think about that. Let's divide our graph up into 3 sections because there's, you know, we can identify 3 separate sections there. Let's find out how far we traveled in this first hour. In the first hour, we were going 120 kilometers an hour, 120 kilometers per hour. For how long? For 1 hour. Yes, so multiplied by 1 hour, that gives us 120 kilometers. So in this first hour, we traveled 120 kilometers. Let me just write the formula above it. Speed times time equals distance. You already know that, but just to make sure. All right, so here I traveled 120 kilometers. Let's see how far I traveled in this time interval. I started at a speed of 120. I ended up at a speed of 100. It's a straight line. We can say that on the average, I drove 110 kilometers an hour. Yes, I drove 110 kilometers an hour for half an hour. That gives us a distance traveled of 55 kilometers. Yes, so here, 55 kilometers. Here, this part, I spent half an hour at 100 kilometers an hour, right? So I went 100 kilometers an hour for half an hour. So how far did I get? I got a distance of 50 kilometers. So distance traveled in the first hour is 120 kilometers. Distance traveled in the half an hour after that was 55 kilometers. And then in my last half an hour, I drove 50 kilometers. So if I add those up, I find the total distance traveled. 5, 12, 2. So I drove 225 kilometers. And as you can see, that was actually calculating the area of these separate sections. Here, I did 120, which is the height. The width is an hour. 120 times 1 is 120. Here, of course, if you want to cut it up like that, the area of this rectangle would be 100 times a half, which is 50. Yes. Here we have a triangle of height 20, width a half, 0.5, and it's a triangle, so let me just do this. The area of a triangle is 1/2 base times height, right? So 1/2, the base is also a half, 0.5, times the height. is 20. Half of 20 is 10. Half of 10 is 5. So that would be 5. And here the area is, of course, 1/2 times 100, which is 50. So here you can imagine it as a little triangle and a rectangle and add them up. 5 plus 50 is 55. Or you take the average speed and use that as its height. Yes, like I did here. I took 110, which is the average of 120 and 100. 110 as its height, and multiply that by the base, which is 1/2. Yes, either way works. Just as long as you realize that to find the distance traveled, you calculate the area under the graph. Okay, you should be all set. Have fun with this. See you next time.